Now let's get into scientific notation. With question 23, what is this number in scientific notation? So as we can look at our answer choices A through D, for scientific notation, we're going to somehow we want to rewrite this so that we don't have so many zeros. In this case, this is a really small number, and so we have a lot of zeros to the left of the non-zero digits, this 325. So we need to take this decimal point and we need to see how many spaces we can move. And the common way to write scientific notation is to have one non-zero value on the left and then a decimal followed by any other non-zero or any other values. It could be zero after that. So basically we want to move the decimal point between the 3 and the 2. So if we take this and we can count how many spots we need to move, 1, 2, 3, 4, 5, 6. So we're going to move the decimal point 6 spaces to the right, and we will have the number 3.25. And for scientific notation, you multiply that by 10 to some exponent. Since this is the way I remember it, it's a really small number, so I'm going to have a negative number that coincides with how many spots I moved with that decimal point. So we're going to go 10 to the negative 6, which is answer choice C. You may have remembered it that if you move the decimal point to the right, it's a negative exponent. Moving the decimal point to the left is going to be a positive exponent. But for me, I found it easier to just think if I have a really small number, I'm going to move the decimal and have a negative exponent. If I have a really big number, I'm going to move the decimal point and have a positive exponent. Next, question number 24. What is this number in scientific notation? And this is a really big number. Now again, just as in the previous problem, we want to move the decimal point to where there's only one non-zero value to the left of the decimal point. So we're going to want to move it here between the 4 and the 3. So we're going to have 4.38 times 10. And also in saying that, look at our answer choices here. We know it's going to be 4.38 something, but we just don't know. If we looked back in question 23, there was some variety in what that number is going to be, and we know it's going to be the 3.25, or you should know 3.25. Back to question number 24. Like I had previously said, this is a really large number, so we're going to have a positive exponent, and it is based on how many times we move this decimal point. We have an understood one at the end of this last zero, and let's see how many times we'll need to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 spots to the left. That gives us 4.38 times 10 to the 11th, which is answer choice D. With question 25, we're going to look at data interpretation, and it has a chart. We've already had a couple of charts already, and we'll have a few others, but this is one strictly focused on charts. Jen is planning to buy cookies from a bakery for her cousin's birthday party. She needs 50 cookies. When she gets to the bakery, she sees the chart below. What's the minimum price Jen will pay for 50 cookies? So this is a common practice in some businesses. The more that you buy, you may get a little bit of a discount. So we also need to know in this question what dozen is. 1 dozen is 12. And so we want to look at, because it looks like these discounted prices are based on a dozen. So 2 dozen is going to be 24. 1 dozen is 12, and then of course the individual is each one. So what I want to look at, because it looks like per unit we can get a cheaper value at $10.75, so we want to divide 50 by 24, and we know that's going to go 2 with a remainder of 2, because 2 times 24 is 48. So we can get 2 dozen at $10.75, and we need 2 of those. And when we do that, you can plug that into your calculator or do that here. You're going to get $21.50 But we need 2 more because remember, 24 times 2 is just 48. We're going to have to get 2 of these individuals. That's going to add another $1, making it $22.50, and that's how much we would pay there. Versus now you would probably need to look at each individual thing. If you had paid individually 50 cents for 50 cookies, 50 times 0.5, that's going to cost $25. So you're saving when you go this route of 2 dozen. If you go 1 dozen, you're going to have to go $5.50 times 4, which gives us $22 plus another $1 because times 4 gives us 48, plus $1, we're at $23. So you're saving 50 cents with this 2 dozen route, and that is answer choice C. That's the cheapest price. Question 26, we're going to be looking at rates. Mike is driving to see the New York Yankees play. It is 300 miles to the interstate exit that he needs to reach. He drives an average speed of 65 miles per hour. If he has already driven 3 hours but wants to get to the exit in 1.5 more hours, how many miles per hour faster should he drive? So let's just think about this. He's already going 65 miles an hour on average. If we look at our answer choice, this is asking how many miles per hour faster than the 65. Surely it's not going to be 50 or 65 because that's adding that into the 65 miles per hour. So just be thinking of that as you're looking at your answer choices. What would really make sense? So it's 300 miles to the interstate from the point he needs to go. He's been driving 65 miles per hour, and he's already driven 3 hours. But he wants to get there in 1.5 hours. So we need to see how much faster. So let's see how many miles he's already gone in this 3 hours. So if he goes 65 miles per hour times 3 hours. In 3 hours, that's how much he's gone. And you can look, your units cancel. 65 times 3. He has already driven 195 miles. He needs to go 300 total. So I'm going to take the 300 and subtract that from 195. He has 105 miles to go. But he wants to do that in 1.5 hours. So his rate of driving should be 105 miles divided by 1.5 hours. And let's see what that gets as his rate. If we take 105, divide that by 1.5, I get 70 miles per hour. That's how fast he should go from here on out. So that's going to be an increase from 65 of 5 miles per hour. So that would be answer choice B. 27 says a machine makes 10 widgets per minute. A second machine makes 25 widgets per minute. The second machine starts making widgets 3 minutes after the first machine. Both machines stopped making widgets 10 minutes after the first machine started. Together, the 2 machines make how many widgets? So let's look at machine 1 begins at time 0. And this one makes 10 widgets per minute. Okay. The second machine, machine 2, is going to start, it goes 25 widgets per minute. And it starts 3 minutes after. So we're going to say this is 3 minutes from here to here. We have a 3-minute time period. And they're both going to stop at 10 minutes from the start of the first one. So this is at 10 minutes, which means how long has this been going? 10 minus 3. This one has been going 7 minutes here. But they both stop at 10 minutes. And we want to know how many they've been making in this time period. So let's look at the first one. We've got to look at each one individually. Machine 1 makes 10 per minute, and it's been going 10 minutes. So that one makes 10 times 10, 100 widgets. This one has been going 7 minutes, and it makes 25 per minute. So 25 times 7, which is 175. We're going to add those 2 up, and we get 275 widgets in that time period. Answer choice D. Now let's take a look at some perimeter questions. Number 28 says figure ABCD is a square with side length of 4. So I'm going to go ahead and label that. Side length of 4, side length of 4. Point E is the midpoint of AB. That's right here. Point F is the midpoint of BC. And point G is the midpoint of CD. What is the perimeter of the region AEFGD? And it's already colored in for us. So knowing that it's a midpoint, that's going to give us some information. Now we're looking for perimeter, and perimeter means the length around an object. We're looking around an object. I drew a circle, but in this case, it's going to be looking at this object right here inside of our square. So if we're looking at this, what we need to know is we need to know this outer perimeter. That's the length we're looking at. We know that, let's look at the things we know for sure. We know that AD is a length of 4. And we know since E and G are midpoints, that from A to E and D to G, that's going to be half of 4, which is 2. So we're at least at 4, 5, 6, 7, 8. So just looking at that alone, if you're quickly trying to do something, you know that you can eliminate A because that is only 8. We still have to take care of EF and FG. So how can we do that? Well, let's think about this. I like to think, what information do I have and how can I find that? I'm looking right here at EBF, and it is a triangle, right? I'm going to label it EBF, and we need to know what this is right here. Well, we know from E to B is 2 because of that midpoint. Same thing, F is the midpoint, so we need to know this is 2. This is a right triangle because it is a square. We could use Pythagorean theorem to find EF, and that's just 2 squared plus 2 squared equals, I'm going to call it x squared. We'll name this x. So 4 plus 4 equals x squared. 8 equals x squared. And so to find x, we're going to take the square root of 8, and that is 2 on the square root of 2. Make sure you know how to work radicals, and that is an example right there. So we have that this value is 2 on the square root of 2. And now, and I'm getting that right there. And this is also 2 on the square root of 2 for the same reason. So when we're adding this up, we're going to add up 4 plus 2 plus 2 plus 2 on the square root of 2 plus 2 on the square root of 2. And so right here, we almost treat radicals sort of like we do when we have variables. We can only add up things that are like and how they're formed. So we have 4 plus 2 is 8. Plus, now we can add these two up. We're going to have, because they both have radical 2, we can add what values are in the front. 2 plus 2 gives us 4. And then we have on the square root of 2. So our answer is going to be C. 8 plus 4 on the square root of 2 is the perimeter. Question 29 says that the perimeter of a parallelogram is 32. The length of one side is 9. What are the lengths of the other 3 sides? So we need to know what a parallelogram is, and that's just a 4-sided figure where opposite sides are parallel. Examples are rectangles, squares, but you also have rhombuses. So, or it could be that. So let's just draw something like this. We have a rectangle, and we know that the full perimeter of this is 32. So perimeter equals 32. When we're looking at any kind of rectangle or basically any parallelogram, the perimeter is equal to twice the length plus twice the width. We're given perimeter of 32. What else do we know? It said the length of one side is 9. So we also know that the length of the other side is 9. So we're going to have 2 of the 9s. We don't know what W is though, so we need to solve for W. So we have 32 is equal to 18 plus 2 times the width. Let's solve for the width. Subtract 18 from 32, and we get 14 is equal to 2w. Divide through by 2, and we're going to get that w is equal to 7. So it asks for the lengths in feet of the other 3 sides. So don't forget, one of those side lengths is 9. We're going to have another side length to be 9, and then we just found these sides to be 7. So we're looking for the combination of 9, 7, 7, which is C. Question 30 says, in the figure below, adjacent sides meet at right angles. So basically that's just telling us, like right here we have a right angle, and lengths are given in feet. What is the perimeter of the figure in feet? So again, we're just going to be adding up the lengths of these sides, but you may ask, we don't have this side length, or this side length, or this side length, or this one, but we can figure it out with what we're given. Okay, so let's take a look at this. If this total side length is 20, then since we meet in right angles, our lines are parallel, would not this plus this come to be 20? It would, wouldn't it? We have this full length, that's 20. Same thing on the opposite side. From here to here, these should be 25. So to get the perimeter just adding up, we have 2 times 20 plus 2 times 25. So that gives us 40 plus 50, which is 90. And that is answer choice D. Looking at circumference, number 31, what is the circumference of a circle with a radius of 3 units? And it tells us to use 3.14 for pi. Circumference is what we use for perimeter of a circle. So with this circle, we're looking around the circle. That's what we're looking for. And we have a formula that you should be familiar with. The circumference is equal to 2 pi r. R being the radius. And we're given the radius here, and we have a value to plug in for pi. So it tells us to plug in 3.14 for pi, and our radius is 3 units. So let's plug that in. It's 6 times 3.14, and that is equal to 18.84, which is answer choice D. Question 32 says an 8.5-inch diameter bowling ball is released at the foul line and starts rolling towards the head pin. If it is 60 feet from the foul line to the head pin, how many revolutions will the ball make before it hits the head pin? So let's think about what we're looking at here. We're at a bowling alley. We have a foul line and all the way to that first head pin. So we're basically looking at this length. We want to know, well, we need to know this length. We're given it to be 60 feet. 60 feet. And we have a ball here at the start of that has a diameter of 8.5 inches. Oh, I'm going to have to be careful of my units because I'm in inches here, feet here. And they want to know how many times about does it roll, the revolutions. Thinking about a ball rolling. As it rolls, we're getting the outside, what measure? Circumference. That's what we're looking for, is what is the circumference. We need to know that. One full circumference is a revolution, so that will help us know how many revolutions. So first, let's think about the circumference of this ball. We just said it is equal to 2 pi r. So I'm going to use pi from my calculator. That's going to give me the best value. Now, we need r, but we're given d. But we know that if given d, we can take half of that to find r. So 8.5 divided by 2 gives us 4.25. Or you could use the formula C equals pi d, because there's your 2r, which is d. I'm going to go ahead, though, and plug in here 2 pi times 4.25. And again, I'm going to use pi from my calculator, so it's going to be an approximate value. So 2 times 4.25 times, and make sure you know where pi is on your calculator. I'm going to get approximately, and I'm going to go out to 4 decimal points, 26.7035, and this is inches. That's one circumference of that bowling ball. We need to know how many circumference or revolutions in 60 feet. So at this point, we need to either change 60 feet to inches or this 26.7035 inches to feet. I'm going to go 60 feet, I think, to inches. So 60 feet, and you need to know this conversion, 12 inches in 1 foot. So I'm going to take 60 and multiply it by 12, and I get 720 inches. So that's the total length of that bowling alley. So now I want to take 720 inches, divide that 26.7035, because that was 1 revolution, and let's see how many revolutions we get. Plug that into your calculator, and I get approximately 26.96, which is going to be closest to answer choice D. If I had probably carried out my pi all the way through to even this calculation here and didn't round here, I would have gotten the 0.98. But I wanted to make sure you saw each individual step. Most of the time I'm probably going to keep it in my calculator and use those values, but that's what we have here, and that's close enough. Now let's look at area of a rectangle. Question number 33 said Mike plans to use grass seed in the backyard of his newly built home. His backyard is a 36 by 40 rectangular plot. That's important, but he has installed a 12 by 24 in-ground pool. If each bag of grass seed covers 375 square feet, how many bags will he need to purchase? So we need the area of the grassy area. So let's first look at the full size of the backyard, which is this 36 by 40. So the area of a rectangle is equal to length times width, and we're given that to be 36 times 40. Plug that into your calculator, and we get 1440 square feet. But he's got this pool that we need to subtract out, the 12 by 24 pool. So that was the full lawn. For the pool, the area is going to be 12 times 24, which is 288 square feet. I need to subtract that from the 1440. And I get 1152 square feet. Now, where does that come into play? Our ultimate question was how many bags of grass seed do we need? One bag covers 375 square feet, and we've got 1152. So I need to take my 1152, divide it by 375 to figure out how many bags I need. And I get 3.072. So what happens if I only get 3 bags? I've got a portion that's left over, and I'm not going to cover it with the grass seed. So I'm going to have to go up to 4. I'm going to need 4 bags. That's answer choice C. Question 34 says, what percent of the area of the larger rectangle is the area of the smaller shaded region? So first of all, we're going to ultimately look for a percent, but we need the larger rectangle and the smaller. So let's take a look at the larger. First of all, it looks like the area of the larger one is going to be the 18 by 15. And when we plug that in, I get 270. Now, what about this? The measurement of this area, if from here to here is 7, then from this point to this point is going to be 18 minus 7, which is equal to 11. So that is one dimension. And now we need to know from here to here. This is going to be equal to that 15 minus 5, which is 10. So 11 times 10 is 110. So again, now we're going to our percent. We're going to have the area of the smaller divided by the area of the larger. And let's see what that percent is. 110 divided by 270 is going to be approximately 40.7%. And that is answer choice C. Again, we've worked on percents. Make sure you're familiar with them. Number 35, a rectangle has an area of 36 square feet and a perimeter of 26. What is the longest of the side lengths in the feet of the rectangle? Okay, so we're given area, which is 36 square feet, and we know that area of a rectangle is length times width. And it also gives us that perimeter is 26, and of a rectangle, it is twice the length plus twice the width. What's the longest of the side? So it looks like we don't know length or width, but we have two equations and two unknowns. So we can calculate this. So I'm going to write one in terms of the other, and it really doesn't matter because basically we're going to need to find both of them to determine which is the longest. So I'm just going to rewrite this, and let's say I'm going to solve for L. So that means I'm going to divide through by W. So L is equal to 36 over W. Let's plug that in over here. We've got 26 is equal to, for L, I'm going to plug in 36 over W plus 2W. So let's calculate here. We have 26 is equal to 72 over W plus 2W. I've got a W in the denominator. I need to get rid of that, so I'm going to multiply everything through by W. And I get 26W equals 72 plus 2W squared. Looks like we're going to need a little bit more room. I'm going to come down here. So let's rewrite this. I do notice that I have all even numbers here, so I'm going to divide through by 2. And I get W squared. I'm going to bring this 26 to the other side, minus 13W plus 36 equals 0, because I have the W that I'm keeping that on the same side. So I can solve for W here. This is a equation. We're going to have, you need to be able to solve this quadratic equation, and I am solving it by factoring. And so I get a value of W can be 9 and W can be 4. So basically this is giving us our length and our width. It's listing it as our W, but if you think about it, A equals 36, and so 9 times 4 is 36. It's asking then for the longest length between 9 and 4. It's going to be the 9, and that's answer choice D. Question 36 that we've already gotten a little bit of. Let me kind of mark this out here. In the figure below, the vertices of rectangle ABCD have XY coordinates. What is the area of this rectangle? So remember, area of a rectangle is length times width. How can we find this in this coordinate plane with these points? We can look, we need to know how long is this length. And remember, this is along the x-axis, so we could look at the x values. They go from 2 to 6. So from 2 to 6, that's a difference of 4. So that gives us one length. And then what about here? We could look at from C to B. This is on our y-axis. We could look at the change in the y from 2 to 7. So 7 minus 2 is going to give us 5. So that gives us an area of 20. Answer choice C. Looking at area of a circle, 37 asks what's the area in meters square of a circle with a diameter of 6 meters, and we're supposed to use this for pi. So here's another formula we need to know. Area of a circle equals pi r squared. It uses r, we're given diameter. If diameter is 6, then we know that r is half of that, which is 3. So we can plug this in. We're to use 3.14. Don't forget to square your r. So really that's 9 times 3.14, and we get 28.26 which is answer choice D. 38, Jill installed a 9-foot leash to a stake right outside her front door. What is the outside area in square feet the dog can reach from the stake? Okay, so here is her door, and she's got this stake, and imagine the dog on the leash can go only so far, right? What does that look like? A half circle, right? So what is the outside area? So he can go anywhere inside here as long as the leash is, which is, it's a 9-foot leash. And that is equivalent to, on a circle, the radius. So again, area equals pi r squared, but we're just doing half of that, which is 1/2 pi r squared. Also notice in your answer choices we have pi. So we can leave that. We don't have to plug anything in. We have our value for r. So let's go 1/2 pi 9 squared, which is 81. We would have 81 over 2 pi. When we plug that into our calculator, 81 divided by 2 is 40.5 pi, which is answer choice C.